Okay, so today's CLT is I can determine a continuous probability distribution. So before we did a discrete probability distribution where you could only have, say, 0, 1, 2, 3, a whole number of successes. Hey, Paraguay?
I was looking up the little checks once.
I was doing continuous variables. Anyways, so we did things that we can count. I'm not sure if that works. It's unhooked because it wouldn't show up. It kept going. Okay. Discrete were things that we can count, so you could have 0, 1, 2, 3 successes, something like that. We did a binomial distribution, which was also a type of discrete distribution, and for that there was more conditions. It was still things, numbers of successes that you could count, but a binomial had 2 conditions. What were they?
It has to have
Only 2 outcomes, which is like success and what also is true. So remember, like if it was marbles without replacement, then that wouldn't count. So each trial has to be independent of each other. They're not going to be 2 outcomes. Then we did a Poisson distribution, and for a Poisson distribution, what sorts of things would be true?
The event is something that can be counted in whole numbers.
That's true.
Occurrences are independent. Average frequency of occurrence from the time period in question is z. It's possible to count many events of occur.
So basically, you have to be able to find an average for a given time period because that's the only parameter for Poisson. And it does have to be something that you can count. Okay, so now I'm changing. So those were discrete variables where we were going, things you could count, 0, 1, 2, etc. Now it's going to be continuous. So for continuous, it might be what's the probability we're going to get between 1 and 3 inches of rain. Okay, so now it's going to be a range of values. It might be 1, 2, or 3. It could be 1.5 inches of rain. Okay, so that's a continuous probability where it can take on continuous values for things that you can measure. Okay, and the way that you find these out is with integrals. Okay, and so what you'll do is you'll have a function that describes the probability of different events occurring. Okay, so this particular one has height on it. It's kind of tiny there, but these are different heights in inches. And this is the probability of all of those heights. Now this particular one looks like a normal distribution. It looks like the bell-shaped curve. That's the most famous of continuous distributions, but it's not the only kind. Okay, so if you integrate under the curve, you get the probability of something happening. Well, what should all the probabilities add up to get? 1. So for the normal distribution curve, the area under the curve from negative infinity to infinity has to be 1. Now we know that that can be possible, because we've had bounded things, bounded areas. So we would assume that over here, the probabilities are really getting infinitesimally small. Okay. Now, there's another way around it that they'll do. They might define the function and say from 0 to 2. So I'll draw it on the board, but then nobody can see it on the video. So another thing that they like to do is define a function. And that was awful. And they might say that it looks like this from 2 to 3. Or, just give it a nice linear function, and say it's 0 everywhere else. And then this area under the curve would be equal to 1. That's the probability of everything that could possibly occur. Would be 1, and then everywhere else it's 0. So sometimes they'll cheat the system. Okay, if the only values that could occur is that could be between 2 and 3. So sometimes they'll define it that way. But whatever your probability distribution function is, the area under the curve from negative to infinity has to be 1, because that would add up to 100% of the things that could happen. And the function, remember that you can't have negative probability, so the function is going to have to be above the x-axis the entire time. Okay, and if you want to find out the probability, let's say this is probability function for the amount of rainfall, if you want to find the probability that there's between 1 and 3 inches of rainfall, you would just integrate this function from 1 to 3, if that's what that function represented. Now, for this particular type, it doesn't matter if it's less than or less than or equal to, because what do you get if I said, if I did the integral from 3 to 3 of this function? 0. Okay, so I can't tell you the probability of getting 3 inches of rain, because I would just get 0 if I integrated. I could tell you the probability of getting between 2.99 and 3.001 inches of rain, which might hopefully be good enough. Okay, but I can't tell you the probability of getting one exact value. So for the continuous functions, it's not going to matter if it's less than or equal to. Okay, so I can make both of these or equal to. 1 equal to and 1 not. It just doesn't matter. So it's really, really important for like binomial and Poisson and all that, because you're counting those values. For binomial, less than or equal to 2 means I better include the 2. For this guy, less than or equal to 2, doesn't matter if I include the 2 or not, because I can't find the probability of any one specific value by itself. Does that make sense? All right. So here's one where it kind of cheats the system, like I was telling you. So it says that this is basically it's a probability distribution function. Well, it wants me to verify it. So in order for it to be true, it does have to be above the x-axis for the whole interval from 2 to 10. So I could just graph it and see. I could do a sine term. See, that would be another way. But I'm going to go ahead and graph it. And actually, I think I'm going to graph it with a piecewise because it was only that from 2 to 10. So I'm going to do a little piecewise function. And I put in that guy. He's going to be a little tedious to put in, but we can get it. Alright, so I want it to look like that from 2 to 10, so I'm going to put 2 is less than or equal to x. Where did it go? I hit something. Okay, I'll think it. No, that's the wrong one. Okay, I lost it, so I'm going to go over here. Did I hit cancel or what did I hit? Anybody know? Okay, I'll just do it from here. I'm going to change this function. This is one I was doing with another class. Yes.
If everyone, like in this class, went to the nurse and said that we were sick and went home, would that increase our chances of getting out of school tomorrow?
Well, you're talking about trying to make up for the whole entire county, you know?
Well,
so
That way we can leave school and spit on other kids.
you can go to other schools and infect them with disease. It's a foolproof plan.
or is it? Okay, so I'm going to change these 2 to 10. Okay, and then if you just put 0 for the other part, it actually, let me pick this up and move it. It says 0 else, meaning 0 everywhere else. So you can kind of see what this guy looks like. We can make the window a little bit better. We only need to go up to like 1. And maybe go to 15 here. Okay, I should have made it not go as low. But you get the basic idea here. So the area under that has to be 1, and they're saying it's 0 everywhere else. Okay, we can visually see it's above the x-axis, so that's useful. So if we look at this guy, it says verify this probability distribution function. We can say between 2 and 10, f of x is greater than or equal to 0. Or you could say for the whole interval, it's greater than or equal to 0 because it's 0 everywhere else. Okay, so that's one of the things that has to be true. The other thing is if you integrate from negative infinity to infinity, you're supposed to get 1. Okay. Now, I don't really have to worry about it. I could divide it up, negative infinity to 2, plus the integral from 2 to 10, plus the integral from 10 to infinity. But what's the integral from negative infinity to 2 going to be? 0. And then 1 from 10 to infinity? Also 0, by the way. I am getting a signal from 0 from the back. Okay, so really all I need to do is figure out what it is from 2 to 10. And frankly, I'd like to take out my constant. Seems like that would just be in the way. Okay, so to verify, I just have to hope that this guy comes out to be 1. So what do I get when I integrate this?
24x.
You're doing derivatives. So you keep the 12. What do you get when you integrate x squared? And then this guy?
1/4 x to the 4th.
Perfect. And then keep 20. You're adding 1
X to the 2.
times the reciprocal of the new power. Okay, you don't need plus c because you have bounds. Okay, so you have 1 over 512, and go ahead and do this. 4x cubed minus, simplify it a little bit, 4th x to the 4th minus 10x squared.
You got 20%.
That's 10, thank you. I do that a lot, actually. Okay, so you would have to put in 10 cubed minus the 4th times 10 to the 4th minus 10 times 10 to the 2nd minus the quantity 4 times 2 cubed minus the 4th. Oh, is it going to fit? Times 2 to the 4th minus 10 times 2 squared. I'll give you one guess what that comes out to be.
1.
Right. Now, for a lot of this, you can set it up, put the integral in the calculator. And then the next part says, find the probability you're between 5 and 8. So what do you think I'm going to do? Yep, just integrate it from 5 to 8. And you can put this in on your calculator just to get a value. Do you all remember how to put it on your calculator? Or would you like it demonstrated? Yes.
Where did the last one is?
Well, you see, Diet Caffeine-free Pepsi tastes better than Diet Caffeine-free Pepsi. Also like Diet Caffeine-free Dr. Pepper.
Have you ever had a wild cherry Pepsi?
Yes.
It is good.
Yes. Well, it would just show that function for all the values instead of just between 2 and 10. So, in other words, the area, it might not be positive if you just did that part. Because remember when I looked at it, where's my Promethean pen? Actually, let me just do it from here. Okay, so if I took this guy, maybe I can copy it.
Do you know what the first name of that Dr. Johnson, the superintendent guy is?
Isn't it Brian?
I'll look him up on Twitter.
I mean, okay, so Tanner asked me, what if we didn't make that just from 2 to 10, so that's why I'm messing around here. I'm going to do another graph page. Okay, so you see the curve? So the area under this, you think that's greater than 1?
Yes.
And I don't even know if we look at it, let's look at it going out a little farther, maybe 100. See, it also has some, hey Tanner, it also has some negative regions. So I couldn't use the function. I'm okay that this is positive, but the area gets greater than 1. And over here, I can't have negative probabilities. Yeah, we did put the bounds on it. We told it to graph it from 2 to 10. There may be. I don't remember. This is just the fastest way I knew to do it. Could you do it in there? I know on the 84 it was just literally like comma 2, comma 10, but I'm not sure on this one because it seems like how I usually bound it is. We can try it, but I suspect I'd have to Google to see if there was a way. I didn't like that. I don't know. That was just the easiest way I could see to graph it that way from 2 to 10. There is probably another shortcut or way around it, but I don't know what it is. But anyhow, head check. Did you get an answer for that?
Yeah.
What was it?
0.567.
Okay. Yeah. Can you what? I don't know. Like right now, I'd probably pick Uncle Blake for the reach.
I think.
I understand.
But if someone had like a gun to your head, you had to choose between David, Jack, and Max. Would that be Jack?
I'd take David. It obviously can't be Max, and Jack just doesn't show.
Alright. Well, you're wrong. I hope that I don't have to make this choice. I hope you're not planning. Anyhow, find the value k such that the following represents a probability distribution function. Lots.
Integrated. Find it equal to 1.
Yep, integrate it from where to where?
0 to 2.
Okay, is it okay with you if I take the k out? I mean, it's constant, right? And that has to equal 1. Okay, so we could do it by hand. You don't have to do it by hand. You want to do it by hand? Sadness. All right, you got it. Okay, so if you weren't, you could put this whole thing in on the calculator and get a value. Okay, most likely this will be tested on the calculator portion, but there's always a chance that it's not, so we'll practice. So what would you get when you integrate 2x squared?
2 times 1/3.
And then minus. And also not too bad since it's 0 to 2. We won't have to worry about the 0 too much. Okay, so we'd have 2/3 times 2 cubed minus 1/4 times 2 to the 4th. And then when we put 0 all the way through, that's just going to be 0. So we have 16/3 minus 16 plus 4, so just 4. So we can do 16/3 minus 12/3. So we've got k times 4/3 equals 1. So if you just put all that on your calculator, you would have also gotten 4/3, or 1.3 repeating. What can I do to solve that? Pear boy, what do you think? Apple boy.
To solve that, we should do, are we solving for k?
You got it?
So I divide 1 by 4/3, and that's what k would be.
I would agree. And dividing by 4/3, are you okay if I just multiply by?
3/4.
Okay.
Exactly.
All right. So k is just a whopping.
3/4.
All right. Hey, how are you? Doing great. Well, since there's other small classes, they don't really know. Okay, so if you take a look at this, these are for the expected values. This is from your formula sheet. The top of it's kind of repetitive, so I'm ignoring that one. But if you look right here, you see expected value of a discrete random variable versus the expected value of a continuous random variable, if you'll notice they're very similar to each other. So on this one with the discrete random variable, you're adding up each value times the probability of getting that value. For continuous, to get the expected value, it's kind of like that because the integral is like adding up the x is each value and the probability of getting that value you're getting by integrating the function. So it's a very similar analysis. It's just an integral instead of adding up individual values. Okay. Again, there's so many different for expected value and all these things. You're just going to go to your formula sheet. There's too many to remember. Okay. So, the big deal is remembering if you're finding probability, you're just integrating. If you're finding expected value, you're integrating the function times x. So sometimes people forget which one they're doing. Probability of something isn't on your formula sheet, you're just integrating the function. Expected value, which is same as average, you're integrating x times whatever the function is. Okay, but that's on your formula sheet. All right. So,
Any dark chocolate kinds in here want my face and make sure value
okay, flu's going around, so let's just make sure and like pass all the food and
I am healthy as a horse.
Besides the flu's experience, it's like a bucket list thing. You just gotta have the flu sometimes in life.
I mean, I think I've covered that one.
I don't think I've ever had that.
Actually, to be honest, I just feel like I must have because I'm pretty well. So,
There's no way you can like not have the flu at some point. I feel like.
yeah. You don't necessarily go to the doctor and get like diagnosed with it, but you're sick in bed and you feel horrible.
I mean, they did.
All right, here we go. So we've got a function and asked me to find mu. What on earth are they talking about?
Average.
The average. How do I find it?
Oh, we integrate x times the function.
There you go. Okay, so it's just x times the function, like you just said. Now you're supposed to do this from negative infinity to infinity, but for me, I only need to do it from 0 to 2 since everywhere else is 0 anyways. And that's going to be how you find it. Okay, so from 0 to 2, should we go ahead and distribute all this at once? Okay, so you're really distributing 3/4 x cubed times each of these. So what would you get when you do 3/4 x cubed times 2? Yes, or 3/2 x to the third minus 3/4 x to the what? Okay, and now I'm going to ask you to just put that in on your calculator. And everybody, please all try at least one of them so we know if you forgot or not. And we can take turns once we get to the point.
I'm trying to keep it.
You are really trying to get the entire school out.
Sure. I'm just a connoisseur.
I know he made trades, so I don't know.
I mean, I'm one of the 3 survivors from middle school yet.
There you go. So all the middle schoolers made everybody sick. There.
This is the original vaccine.
This is what?
This is the original vaccine.
Oh.
Just go around sharing one stuff with you.
Gotcha. Anybody? Ah, you don't know how to do it. See? 1.2 is right. Head chick, would you like to come demonstrate it? We have a few that would like to know how. If I can find the... Would you rather do it from the computer? Because...
I think about the board.
Okay, go ahead.
Like, there's just nobody here.
Okay, so you get this little bookie thing right here, and you click on this one. And you go, what was it, from 0 to 2? And then it was, what was it?
3/2 x to the third.
Let me get some red color. That's my favorite.
Halves
minus 3/4 x to the 4th.
Like this. What was it?
3/4 x to the 4th. April, did you try it? Okay, thank you.
Oh, just a little quicker than me.
Thank you. All right, so for that we got 1.2. Oh, let me get back to the. Okay, now the next part says find the probability that x is less than your average. So they want the probability x is less than 1.2. How do you think you do that?
Probability of 0 to 1 point, or integrate from 0 to 1.2.
I agree. Okay, so it's technically from negative infinity to 1.2, but we only need from 0 to 1.2 of this function. Do I need the x in there, an extra x? No, not when you're finding probabilities. Okay, so now I'm just going to hope somebody will put that in on the calculator. Put it, oh, it's on the right hand side.
My function.
Or you can distribute it. Okay, so we got about 0.4752. All right, 3 more things that you've got to be able to find. The mode. So if you think about the mode, okay, it's the one that occurs the most, right? It's going to be the highest spot on your graph. Okay, so for the mode, if you think about it, if you've got some sort of a function, on the x-axis are your values. You know, like what's the probability you get between 70 and 80 on a test. Okay, and on the y-axis, you've got your probabilities. So if you want the mode, it's not going to be the y value. The y value would be the probability of success. It's going to be the x value where it's the highest. Okay? So what you're looking for here is to find the x value for which the function is as high as possible. Okay? It is exactly like a derivative. Okay, so you're basically going to take you either have to graph the function and just analyze graph, find the max, but you need the x coordinate of the max, or you're going to take the derivative, okay, and make sure that that's where the max is. Okay, so let's do that for the one we just had. Okay, if we want to know where it's the highest. So we got f of x is, shall we go ahead and distribute it? Well, I'll just write the original, and then we'll distribute it. Okay, so that's our function from up here. And distribute it. So 3/2 x squared minus 3/4 x cubed. Take the derivative. What do you think?
3x minus 9/4x.
Okay, and so we can set that equal to 0 to find it. By the way, is that a parabola going up or going down? So the max is going to be at the top, which is the vertex. So I could either set this equal to 0 and solve, or I could use the x equals negative b over 2a, which is the equation for the axis of symmetry, which is on your formula sheet, which would tell you the x-coordinate of the vertex. So, do you want to set equal to 0 or negative b over 2a? Alright, so if we set equal to 0, I'd like to factor something out. Thoughts? Okay, what does that leave?
3 minus 9 4 is x.
Okay, so if we set these equal to 0, we'd have 0 and multiply both sides by 4/9. So reduce. What do I got? 4/3. If you do a little sign chart for f prime of x, you'd have a 0 here and a 0 at 4/3. It's an upside down parabola, so what are your thoughts on the sign chart?
Minus plus minus.
Mm-hmm. So where's the x value for our max?
X value for max.
It's going from plus to minus to
Perfect. Okay. So you're looking for where the derivative changes from positive to negative, from increasing to decreasing. You'd have a max. So 4/3 is your mode. If you graphed the function, you could analyze graph. It would be the x-coordinate of the max if you have access to that. Okay. Now, the other thing you have to be able to find are both medians and percentiles, which are related. I mean, median is a percentile. But the median is the value such that 50% of the area is below and 50% of the area is above. So if you're looking at a particular, if it was a nice symmetrical graph, okay, this was your probability and this was your x. Okay, you're looking for what is the x value such that half the area is below and half the area is above. And so to figure that out, you integrate from negative infinity to you don't know what. So what you're trying to find is this m value. Where is the spot? If I integrate from negative infinity to that m of that curve, that area will be 0.5. So that way, the area to the left is 0.5 and the area to the right is 0.5. So technically, you could also go from m to infinity. 0.5. You could go either way. So that'll be the equation you're trying to solve for the m, and the m is your median. It is the same way for percentiles. So they might ask you to find the 25th percentile. Okay, so if they ask you to find the 25th percentile, they want 25% of the area to be to the left, 75% of the area to be the right. So you would integrate from negative infinity to n, and you would want that to come out to be what? 0.25. That's how you would find out what Q1 is. I just say n equals Q1, not that whole equation. But if you solve for n, that would give you quartile. So that's something they'll ask you to do. If they wanted you to find quartile 3, what would be the difference? Yes, make it equal to 0.75. They could just say the 55th percentile, 0.55. Okay, so we're going to do a couple like that. Alright, so here we got this guy. We want to find a lot of stuff. And by the way, if you're wondering, we have 2 more. So the first thing it asks me to do is find the value. Actually, I'm going to give you a minute. Try the first A and B. I'll just pause the video for a minute and then we'll work on that.
Alright guys, it's me. It's McCormick Part 2. So
Yeah, you're watching, making sure you got it right.
So we're going to find the value of k real quick, so we know that the integral of this has to be equal to 1. So we just give it a real quick k times the integral from 0 to 5 of negative x squared plus 2x plus 15. All that dx'd. And then we know that that has to equal 1, so then we get k. It's pretty simple integration. negative 1/3 x third plus x x squared plus 15x, and then 5 and 0. So we know k times negative 1/3 times 5 cubed plus 5 squared plus 15 times 5, and this all has an x in it, so it's just going to be 0 no matter what. So we'll just add plus 0 there, and then that still has to be equal to 1. So now we're going to add this up, figure out what it is. K, and we have 5 to the third is 125, right? Yeah, we'll say that.
Yes.
And that's not divisible by 3. No, it's not. Negative 125 thirds. So we're going to go ahead and put everything in terms of thirds because that just makes it easier. So this is 25, so we're going to make that 75 thirds. And then this is 15 times 5 is also 75? Or it's 75, right? So then that's going to be 75 times 3 is 225 thirds. And that still equals 1, so add all these up. We get 300 thirds minus 125 thirds, so that's going to be a total of 175 thirds. K equals 1, so K equals 3 175ths. Not a pretty answer, but it's there. Alright, so now...
when you get to the next one, you're going to have to start putting some on down. Set them up.
Alright. So, we're going to do B now, which is mean and mode. So for the mean, we're going to do exactly what we just did, except we're going to integrate with another x in there. So we're going to do, we already know what our k is, so it's 3 1/75 times the integral from 0 to 5 of that times x of this equation right here times x. So I'm just going to go ahead and add an x to each one of those so we can pretend like we just distributed it. So we have negative x cubed plus x squared plus 15x, all that dx. Yeah, we'll get Luke to type it in real quick. Yeah.
1.965.
Okay, you heard it from Luke's mouth? Probably not. It's 1.965. That looks like 4 sig figs, Luke.
Well, I just rounded it because
Alright, so that is the mean. And then now we're going to find the mode, which is the one that appears the most. So, now we have to figure out 3 175 from 0 to, we don't know this, so we're going to put it. Oh, I'm thinking median, yeah. So mode is just the one that appears the most. So for that, we're going to, we're going to take the derivative and find the high point. So the derivative of this bad boy right here is a pretty easy derivative. So our f of x is equal to negative x squared plus 2x plus 15. So that means our f prime. What?
Technically, that's times your k, your constant.
Oh, yeah, yeah.
Although it doesn't make a difference in the next one.
So that's there. So we're just going to leave that there because it is not affected by anything.
It doesn't matter if you want to.
So we have negative 2x plus 2 plus 0. So we're just going to go ahead and find what that equals real quick. What did we say? Did we say it equal anything? Oh, yeah. Oh, yeah. So divide that over. That's pretty much gone. So we have negative 2x plus 2 equals 0. And then we can move this 2 over. So, or we'll move the x over, which makes it easier. 2 equals 2x. X equals 1. Pretty simple. We got C. Yeah, we're going to... So now we're going to find the median of it. So we're on the median now. So we're going to do what I tried to do earlier and say that, what did I try to do earlier? Oh, yeah, integral of everything. So 3,170. 3,175 times the integral from 0 to, we don't know what we're trying to get to, so we're going to give it a big old W, because that's fun. Why would we do M? This is the W for Wombo. Yeah, I think we have everybody else. For Luke, I looked right at you and said we don't have anybody else with a W in here.
And me, April, and Luke are all we need. And if you put McCormick upside down, it's W.
McCormack.
Well, we'll call
So, now we're just going to integrate it from something, from 0 to something. So, negative x squared plus 2x plus 15 dx, 3,175. It's going to equal, we already have it right there. So,
Oh, well, that's true, but I meant the whole thing.
oh yeah, it's going to equal 1/2.
So what about like this dimension?
I mean, we could just solve it, but that's not fun, so we're going to do it this way. So, we already know the integral is this right here. So we have negative 1/3 x cubed plus x squared plus 15x. And that's going to be from 0 to w. So once again, the 0 is going to cancel out. So we know that this equal to 1/2, and we're going to have w's where all the x's are. So 3,175 negative 1/3 w cubed plus w squared plus 15w. And that equals 1/2. Now we're going to insolve it because that's a lot worse than I thought it would.
Well, probably this.
Polytools it. Somebody remember to tell me what that is. Okay, so we're going to go here and we're going to... Where's Polytools exactly?
Menu, algebra. Okay, so he needs that all fixed.
Negative 1/175.
Wasn't there a constant or a half?
No, that's... Oh yeah, we got to move the 1/2 over. We should move the 1/2 over. And...
It's minus so negative 2.5. What is that last one? Did you put in 181?
You gotta divide it by instead of negative.
What just happened?
You. Okay, now
Hey,
Blake
that's
is.
not always your edge.
Oh, yeah, that's it.
Maybe it's simplified for you already. No, 1, 2, 1. No, you're good. It's just 9 over 35. You had it.
Hold on, it just messed up. What happened?
No, A2 is 3 over 175. But the next one is fine. You're good. Hit okay. That was fine. Or it was 29, just not 2.
Well, yeah.
Yeah, it is.
It is. Oh, mine's just.
I think I was gonna.
Mine just says, no, change the 29 to just a 9. Is that right?
Yeah, which one of those you think it is?
Oh wait.
Yeah, it is that one. And why can't it be the other two?
It starts with a negative coefficient, so it's going down and then back up and then down.
But a couple people just told you this only went from 0 to 5,
So it was negative.
so you have to pick the one.
So
If you could say it would be helpful because you're talking about
yeah, so Ms. McCormick just told us that this is from 0 to 5. So the only one that will work between 0.5 is that one right there, the 1.86. That's 3 cycles. Shoot. And go. Messed up. So, you know the median is equal to 1.86, you said? So now we are on find the probability that x is greater than the median.
X is what for you?
X is less than the median.
So what?
So, that's pretty easy. That's 0.5, right? Okay. By definition of the median, the probability that x is less than the median is equal to 0.5. Okay, so now we have to find the first quartile. Why do we have tennis balls?
Mrs. Welland said she did tennis balls.
How when you freshly open a can of tennis balls.
Yeah, but
Jay
it's
did
not
that.
fresh.
Jay did that today, like this morning for his business IA.
Okay, so now we're going to find the
That's what like you.
first quartile, the third quartile, and then the interquartile range. So we're going to do the exact same thing that we did with the median, except we're going to set this equal to 1/4 instead of 1/2. So we're just going to go ahead and skip to this step because we already integrated it and everything.
Can we?
So 3, 175. Yeah. So now we're going to insolve both of these because the first one is our first quartile, the third one is our third quartile. So we're going to go back to the calculator, and we're just going to take this, copy it, paste it, and we're just going to change our, this thing, right, just our constant to 0.25 equals 8. So once again, this one's negative, this one's above 5, so this is going to be our first quartile. So Luke wants to write that one down real quick. We're going to do the same thing. And then 0.75. Above 5, negative, which means 2.8, 2.90 is going to be our third quartile. So we go back to the ladybug.
First one was 0.932.
Yeah, so Q1 equals 0.932. Q3 equals 2.90. So to find our interquartile range, we just subtract them. So 2.90 minus 9, or 0.932, that'll get us like 1.9 something.
Somebody tell them.
1.96.
968. It looks like that's going to be 1.97. Okay, so there's our Q1, Q3, and interquartile range.
Beautiful. My turn.
I really think we should get back nerds.
So maybe after Valentine's Day, a bunch of stuff will go on sale and we'll get some nerds. Right now, we're still working off whatever the last sale I found was. So. Okay, so the last problem I need to do has to do with variance and standard deviation. So this is again copied and pasted from your formula sheet. And you see an equation for variance, variance of a discrete random variable, and variance of a continuous random variable. I think I've used this variance equation once, and I have no idea why I used it, so if I ever remember, I'll tell you. But these work for the only two things that we need. We have it for discrete, we have it for continuous, we're going to use the continuous one. They give you two choices, okay? One is you integrate all of this, okay? Now the dx is telling you where the end of the integral stops. On the second one, you're going from negative infinity of x squared f of x dx, that's the end of the integral, minus mu squared. Okay, so there's just a difference. You can use either one. I'm going to use the second one. Why? I don't know. It's just what I like to do. Okay, does not matter. So, and then, of course, standard deviation is the square root of variance. So all I need is that bottom equation. So it gave me a function. I know it's a continuous function by the way they did it between 0 and 2. They didn't say x equals 0, 1, and 2. So you identify it that way because you're going to be there with 5 billion different things that we've done. You know it's not discrete because it gives you the range of values. Okay? So it wants variance and standard deviation. So to do that, though, you'll notice there's mu. Okay, so I got to find mu first. Do you remember how I found mu? Because the formula is not on this page.
Mu times the x times the
Yes, the function. Okay, so to find the average, you're just going to integrate the function times x. And for us, it'd be from 0 to 2. Okay, so that would just be from 0 to 2. Can we do all that together? What do we got? 6/4 or 3/2 x cubed minus 3/4 x to the 4th. Okay, I would like that. Just put on the calculator. Apple boy. Head shit can't do all the work. Let's just wait for head shake, okay? Alright. Okay, and so now I can find the formula. So I'm going to do variance of x, and it's going to be the integral from 0 to 2 of x squared times the function. Well, you want me to write the regular formula and then plug everything in? I don't know. Okay, so the formula is just this, just to start with. Minus mu squared. So this part's the integral, and then you're subtracting the average squared. So we're just going to go from 0 to 2 of x squared times 3/4 x squared times 2 minus x dx. So you're going to put all that in on your calculator and then subtract the average squared. Is it? Okay. Well, it's supposed to be 4/25. So what is 4/25? Okay, that's 0.16. And then the standard deviation they also asked for, so you just need to take the square root. Yep, 4.4. Okay, and that's it. Your homework is, there's 9 problems, and 2 and 9, you can't use a calculator.